In this video, we will be looking at the power property of logarithms. We'll see it in action, and we will see an algebraic proof of it. So in order to understand the power property, it might be helpful to think about a numeric example, one that we can solve in a way other than using logarithms, as long as we understand the definition of a logarithm. This question asks 3 to what power equals 81. So we're trying to figure out what that power is. Well, we can think about 81 as being 3 to the fourth. So the question of 3 to what power equals 81? Well, 3 to the fourth power. So we know that the value of this expression is supposed to be 4. So what we're going to do is work through the numbers of this using some other stuff we already know and see how it turns out to be 4. One of the things I can do is I can start by rewriting 81 in its other form, 3 to the fourth. Now, 3 to the fourth can also be rewritten as log base 3 of 3 times 3 times 3 times 3. These are equivalent expressions. I haven't done anything magical yet. One of the things we've already learned about is the product property. And the product property of logarithms states that if you have a product inside your argument, this can actually be split up into separate logarithm statements. So this can be written as log base 3 of 3 plus log base 3 of 3 plus log base 3 of 3 plus log base 3 of 3. Now here what we have is a repetitive addition. We are adding the same thing over and over again. So I could actually rewrite this as a multiplication statement. I could say that this is 4 sets of log 3 of 3. So far, all I've done is a little bit of rewriting and reorganizing. If we look at the values of this log base 3 of 3, okay, let's try and figure out what that is. 3 to what power equals 3? Well, the answer to that is 1. So this is 4 times 1. If we look at this expression up here, that's 1 plus 1 plus 1 plus 1. Because each of these is 3 to what power equals 3. 3 to the first power. Are these two statements equivalent to each other? No, 4 times 1 is 4. 1 plus 1 plus 1 plus 1 is 4. The two statements are equivalent to each other. If these two statements are equivalent to each other, that means that the ways that we've written them all along have to be the same. And so if we go back to our original up here in this form, log base 3 of 3 to the fourth power is the same as 4 times log base 3 of 3. So that's the power property in action with numbers. Now, let's try and set up a proof of this using some algebra. This is actually similar to a problem that we did, but I'm going to go ahead and talk through it. This is one of the trickier properties of logarithms to prove, so we have to start somewhere where most of you might not have thought to start, and that is we're just going to pick a variable u, and this is a very common letter that's used in mathematics for random letter we use when we're trying to use it to replace something more complicated. And in this case, the thing that is more complicated is log base b of m. So we're going to use a different way of writing this. Now this is a true statement. These are all variables, and we're saying let this be a true statement, so there's no arguing with it. Now, if that is a true statement, which we said it is, as long as we obey all the rules of algebra, anything else that we write after that should also be a true statement. So let's take a look at this. Now, for reasons you may not understand, what I'm going to do is I'm going to take this and I'm going to write it in exponential form. Okay, so these are the parts that you might not have thought to do if you're doing this on your own. when I have it in this form, because I know where I want to go, I actually want to raise both sides of this equation to the same exponent. And in this case, I want to raise it to the n power. Just like it's okay to square both sides of an equation, it's okay to raise it to some other number, or actually to a variable. Rewriting that, I get b to the un equals m to the n. Now what we will do is we will apply some more logarithm work. I can actually take the logarithm of both sides of an equation. And when I do that, I can take the logarithm in any base that I want, as long as I do the same base on both sides. So here is what I'm going to do. I'm going to take log base b of both sides. Oops. Okay. So all I've done is applied this operation of log base b to both sides of the equation. On the right-hand side, I get log base b of m to the n. Okay, so that whole thing is my argument. On this side, what I need to do is I want to look at this and see if I can't figure out another way of writing this. Remember that a logarithmic expression like this says b to what power equals the argument. So b to what power equals b to the un. That's what this is asking. So I'm thinking of the question that way. Well, what power of b makes b to the un? Why, un does. That means that un is equal to log base b of m to the n. Move that over here. Now going back to our very first statement where we made this statement that u equals log base b of m, I can now rewrite this side, and I'm going to write the n part first. U is log base b of m. That's what this is u times n. And we just said that u times n was equal to log base b of m to the n. So what we see here is what's called the power property of logarithms, wherein if you have an argument with an exponent, you can move that exponent out of the logarithm statement and turn it into a multiplication. And to see it in action, we have it working with numbers over on this side. So I hope that helps explain the power property of logarithms a little bit. And good luck to you on all you're working with it. And some of you may need to just accept this for a little bit and work with it, and then you will start to internalize it.